Alright, welcome back to another lesson on whole numbers. Today we are talking about a more interesting topic, which is estimations. So, what are estimations and what do the questions look like? So basically, for these questions, I can observe that they are actually coming out more and more frequently in the coming years, in these past few years, and even in secondary school, we also see these questions a lot. So, what is the likely volume of a can of soft drink? Or what is the possible mass of a watermelon? So actually for this, there isn't a very fixed set of approach, but what I can do to help is basically show you a few things that actually weigh or measure up to a certain mass or length, and maybe you can use that and apply it during your exams, and this may help. So first we have mass. So mass we usually measure in grams or kilograms. So here are a few things that are in grams. So for 1 gram we have one paper clip. So actually paper clip is quite a common object that you can go and find, you can go and hold it and feel how 1 gram feels like. Or you can also have a small packet of sugar. For 10 gram we have a plastic pen. So actually this one you all may also have it in exams. So it can be a very good reference. For 100 grams we have a bar of soap and a medium sized tomato. And then next we have 1 kg. So 1 kg, I have to specifically state, is a 1 liter of water. So actually usually you won't see 1 liter of water, maybe 1.5 liters of water. So 1.5 liter of water is around 1.5 kg. For 5 kg, we have a pumpkin. So this may be something you've never seen a lot before, but if you all have dumbbells, you all can also go and feel how 5 kg feels like. And lastly 10 kg, a sack of rice, a big sack of rice. If you go to the supermarket, you can also try to carry it to feel how 10 kg feels like. And then for volume, so instead of actually giving by the 100 ml to 500 ml, I actually give some common objects that we see in our everyday life. So for cup, it's around 240 to 350 ml. For Coca-Cola, canned drinks like that, usually those that are thinner, is around 335 ml. I went to the website to search. And for a bottle of drink like green tea is around 500 ml. And like I said, 1.5 liters for bottled water that we usually see in supermarkets. And also this big container that those water dispensers actually use, like water dispensers you can find in gyms, offices, or even some houses also have this. So 18.9 liters is actually quite a lot of water. And then next we have length. So length, there are many things that you can use as a reference. So obviously first we have our standard ruler, which is 15 cm. And then we also have this long ruler that is 30 cm. So long rulers are also quite common, I would say. Or if you have even longer ones, there's like meter ruler or 50 cm rulers. And next we have a guitar. A guitar is around 1 meter. And a door, which is around 2 meters. So for door, you can also think quite logically. Normally people's height maybe around from 1.5 meters to 1.8 meters, or even 1.9 meters if you are very tall. So if a door is shorter than that, you obviously it's not practical. You have to bend down and you get into the door, get into the room or something. So it's not very practical, and it's not realistic. So next, if you've seen a tennis court, about half a tennis court is 10 meters. And now we have a whopping 100 meters. So if you've ever gone to like those stadiums, or even if your school has a school field, and their running track is 400 meters, actually one section of the running track is 100 meters. So around this straight section, this straight line section, which is easier to visualize as compared to the curve section. So that is around 100 meters, which is quite long. It's like about more than actually more than 50 humans, like in a straight lying down on a straight line. Alright, so now that we have this knowledge that we can use, right, we can now solve some of these examples. So like the first example is, so what is the likely volume of a can of soft drink? So alright, before that, actually if you do not have prerequisite knowledge, you can also go and see the options and go and analyze and think. Alright, so the different options are 3.3, 333, 330, and 3,300. Okay, so first, 3.3 milliliters in a can of soft drink is barely anything actually. So is like maybe a drop of water or something. And for reference, this is a 5 milliliter test tube. If you can put that much drink in a soft drink, then you might as well don't charge money for it. Then we have 33 milliliters. It's definitely not enough for a can of drink. So another website says that actually male sip 25 milliliters per sip and female sip 20 milliliters per sip. So if you have 33 milliliters of drinks in a can, you can only sip it like 2 times. And then we have our last option, 3,300 milliliters. That's more than two 1.5 liter bottle waters. And looking at the size comparison, that's confirmed too much. And then next we have before that we have our answer, which is 330 ml. So this one I would say is rather obvious compared to other questions, which I'll go through later. So next, what is the possible mass of the watermelon in the figure below? So the options are 6.5 grams, 65 grams, 6.5 kg, and 65 kg. So talking about everyday items, right? This is where it comes into use. So let's say you have 6 paper clips in your pencil case. You can conveniently use it to measure how about 6 grams feels like. And if you actually go and feel it, right, it's definitely not uh not as heavy as a watermelon, definitely. And next 65 grams, which is a bit better than 6.5 grams, but it's still not, because a plastic pen is 100 grams, and if a watermelon is lighter than a plastic pen, then there's a problem there. And lastly, our option for the most extreme value, which is 65 kg, and 65 kg is around the average body weight of an adult, which leaves this answer impossible. So with that, we have our possible mass, which is 6.5 kg. And lastly, this is a PSLE question that came out a few years ago, and I remember that it made a lot of commotion and discussion as to like what the answer is and how we are supposed to find out. So let's look at it. So mass of 8 $1 coins is 6 grams, 60 grams, 600 grams, or 6 kg. Alright, so for this question, it's a bit more tricky because the extreme values are obviously not possible, but our choice is type between 60 and 600 grams. So for 6 grams, obviously 6 paper clips vs a coin. A coin should be heavier. And 6 kg is impossible for the mass of a coin, because if you have 8 $1 coins in your pocket and the coins are 6 kg, your pants will drop when you walk. So for reference, this is a 5 kg dumbbell, and it is even is even denser, if you know what I mean. But the material is even denser than a coin. And so now we have 60 grams or 600 grams left. So actually, we think about it, 600 grams also quite heavy for some coins. For reference, this 500 to 600 gram mud crab. So if you think about it, eight $1 coins shouldn't be as heavy as a mud crab, right? So with that, we have our answer, which is 60 grams. So this one needs a bit more thinking, but with some actually common knowledge on the mass of uh items that we can see in our daily lives, actually it makes it much easier to solve these type of questions. So with that, we have the moral of the story, and a conclusion to this topic, which is that spotting estimation questions is like finding a needle in a haystack. There's too many already. They can literally ask you like what's the length of a photo, or what's the size of what's the mass of a soft toy. There's too many, and you can't possibly go and find a approach to solve it. But what you can actually do is, if you have time, instead of staying at home, go out more with your parents to go and see at supermarkets or wet markets, and go and look at all these items. I'm sure some of them will have their weight stated or the length stated, and go and experience these things. And with more of this common knowledge, these questions will be much more easy to handle.